Hello students, welcome to Unit 4, Section 4.5. This is the fourth lesson of our unit. I'm going to do the warm-up with you today. It's pretty short. Name the angle opposite AB. So here's side AB. The opposite angle is way over here, not connected. It forms AB when it outreaches. So that is angle C. Name the angle opposite BC. So here we have BC. This side is opposite angle A. Name this side opposite angle A. So here's angle A. It forms, it outreaches to all the way over here to side BC. And then name what's opposite angle C. Here's angle C. It outreaches to AB. So that is side AB. Find the value of x. Well, don't forget that this angle on the exterior is equal to the alternate remote interior angles, which are these two. So we could do x is equal to 30 plus 75 degrees. So x is equal to 105 degrees. Don't forget that's not the only way to solve that problem. If you wanted to, you could do 180 take away 75 take away 30, and you would get let's see, that's 100 take away 105, so we get 75 degrees, which would have been this angle here, 75. And then what you could have done was you could have done 180 take away 75 to find out this angle here, which is 105 degrees. So it is going to be the sum of the two alternate remote interior angles. What other congruence criterion have we used up until this point? We should know this by now. Side, 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 angle, angle, side, angle, 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 side, and the HL theorem. All right, we are ready to start. So what are we doing today? We are doing the isosceles and equilateral triangle theorems. So here we have a triangle, right? And here's a vertex angle. A vertex angle doesn't have to be at the top. It could be at the left, at the right, at the top. This triangle could be spun a little bit. It could look like this. This could be the vertex angle. So it doesn't really matter. The vertex angle, though, is the angle that's in the middle between the two congruent sides. So if you have two congruent sides of a triangle, what we do know is that the angles opposite them are actually congruent as well. So we can draw that in, that it has two congruent base angles. And okay, so those angles will be congruent. In an equilateral, you have all three congruent, and all three are vertex angles, really. So we're going to use and apply the properties of isosceles triangles. So here you have the legs. Here's the legs. These are legs. Base is this right here. The vertex angle is the one that's stuck between the two congruent sides. The base angles are the ones that are along the base. These two, they form the base right here. And we're going to talk about what corollary means and talk about a few other definitions that stem from corollaries. So isosceles triangles are common in the real world. You can find them in structures such as bridges and buildings. The congruent sides of an isosceles triangle are its legs. The third side is the base. The two congruent sides form the vertex angle. The other two triangles are base angles. Two angles are base angles. We already said all of that. An isosceles triangle has a certain type of symmetry about a line through its vertex angle. So what they're saying here is that if I were to draw this line right here, that's perpendicular because my iPad lets me construct a perpendicular right there. But what it's saying is that this actually happens, that there's symmetry on both sides. It can actually be two congruent triangles if cut in half perfectly like that. Okay, so here are some of the things that we know. What we know that if we have two congruent sides, then we have two congruent base angles. If we have two congruent base angles, then we have two congruent sides. So in green are the thens. In green are the thens. Let me change all of this. And then in pink I will do if those, then those, if those, then those. That's what these two state. So the isosceles triangle theorem, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So the base angles are congruent. So A is congruent to B. Again, if the converse is if we flip that around. So if two angles of the triangle are congruent, then the sides opposite the angles are congruent. So opposite the angle, those sides must be congruent. So AC would have to be congruent to BC. And then the bisector of a vertex angle, so something that cuts it in half, cuts exactly in half. So the bisector of the vertex angle of an isosceles triangle is a perpendicular bisector of its base. So if we have this, so if we have that, and if we have that, then bisects AB and it's perpendicular. Then we have everything in green. So if you have this stuff in pink, if you have that, it's an angle bisector at C, which is true, and you have an isosceles triangle, which is AC is congruent to CB, then what you can conclude is not only do you have a perpendicular here at D, you also have a bisector. So it actually bisects that side as well. So these are all the theorems we'll be using today. A corollary is a really big, is a complex word to mean something quite simple. It's a statement that follows with little or no proof required from an already proven statement. For example, it is a theorem in geometry that the angles opposite two congruent sides of a triangle are also congruent. Well, a corollary to that statement is that an equilateral triangle is also equiangular. So a corollary is that if you have two congruent sides, then you have two congruent base angles, right? But what if you have a third congruent side? Well, you have a third congruent base angle, aka it's called equiangular. You have three angles. So then, and if. So if red, then green. Same thing here if you have three base angles. So in isosceles triangle, it says if you have two base angles that are congruent, then the sides opposite them are congruent. That's great. What if you have three? Well, now you have a third base that's congruent. So then is what I drew in green, and what I drew in red is the ifs. And those are corollaries. So if a triangle is equiangular, then the triangle is equilateral, then the triangle is equiangular. If a triangle is equiangular, then the triangle is equilateral. And those are our statements that we're able to make from there. So using the isosceles triangle theorems, explain why each statement is true. So here it says angle WVS is congruent to angle S. Well, let's take a look. Why would WVS be congruent to angle S? Well, that's because we have two congruent sides, so that must mean we have two congruent base angles. So we're going to say, explain why this is true, the isosceles triangle theorem. Triangle theorem states that the angles opposite congruent sides are congruent. That the base angles, maybe I should change that to base, that the base angles opposite congruent sides are congruent. And then what about TR and TS? Well, TR is this part right here, and TS is this part right here. Those are congruent. Let me do that a little bit better. Why would those be congruent? Well, take a look. Angle R is congruent to angle S. So S this is the whole side that's opposite. So not only is WV opposite in this triangle, but take a look at the big triangle. R is here. So RTS is that whole big triangle. And angle S, TR is that whole big triangle. So these are the isosceles, the converse. So I can pretty much copy and paste this over. Well, for the most part, not fully. Let's see. Converse to the isosceles triangle theorem states that the sides opposite congruent base angles are congruent. Now I'll give you a second to write that. Whoops. Let me just make sure that that one's the converse. Yep, the sides are congruent. So converse to the isosceles triangle theorem states that the sides opposite congruent base angles are congruent. Good. Put a weird little tick mark here and a tick mark here. Even it's hard to represent the whole side. Alrighty. Can you deduce that triangle RUV is isosceles? RUV. There's nothing here. I don't know what this angle is right here. I don't know what that is. There's nothing really else to tell me that it is congruent. If it said that this side and this side were congruent, then absolutely it would be. But we're going to say no, not enough information. We don't have any markings. We don't have markings to determine this. Alrighty. Find the value of y. Well, here's a really cool, it looks like I have an angle bisector here. Take a look. There's an angle bisector of an isosceles triangle. So there's things that I know. I know that this needs to be a right angle. I know that this is congruent to this. What I pretty much have are two congruent triangles. So I know that this piece over here has to be 63. Let's take a look. Here's your congruent side. Opposite your congruent side is a congruent angle. So opposite this congruent side is a congruent angle. So really, I have almost all the information I need to solve for y. I can solve a couple different ways. I can either look at one triangle here and find out what the difference what this has to be, so that when it's added to 90 and 63, I get a total of 180. Or I can do 180, take away 63, take away 63. That leaves me with angle M. And I can always divide angle M by 2. So let's do a little bit of work here. I can do 90 plus 63 is 153 degrees. So 180 take away 153. 63, 73, 80. So that's 27 degrees. So I get y is equal to 27 degrees. Or my other method, or I could have done 180 take away 63, take away 63, 612, that would have left me with, let's see, 18, 612, that was 60, 54 degrees. And 54 divided by 2 is 27. So that would have been if I worked with the outside triangle here, if I worked with the outside triangle. If I worked with the inside triangle, that would have been this math right here. So it would have just been this smaller triangle off to the left, off to the right. Either way, the answer here is 27 degrees. All right. Suppose that the measure of angle L is 43 degrees. Find the value of y. So I can do the same thing here. I got congruent triangles right there. Oh, don't forget I got this. Yeah. So I got 40. I'll write in 43 right here. I'll do, you know what? I'll do the outside one. Why not? I'll do the outside one. So 180, take away 43, take away 43. That's 100. That's 94 degrees. 94 divided by 2. 94 divided by 2 is 47. Yes, 47 degrees. So that would be 47 degrees. Each one of these is 47. Again, there's other ways to have done that. I could have done 180, take away 90, take away 43, which would have left me with 47. So that's another way. So I'm going to say y is equivalent to 47 degrees. All right, we are already at the exercise notes, and yep, and then we have a practice to work on in class together. So I'll keep working on these. Complete each statement, explain why it is true. Why is VT, what is congruent to VT? So here's VT, looks like VT's right here, and across from it would have to be the congruent part. Because look at angle T and angle X are congruent and they're base angles. So I'm going to say VT is congruent to VX. And I'm going to say base angles are congruent. And that's the reason why. All right, we have UT. So we have UT is congruent to something is congruent to YX. Well, it looks like the only other thing it could be is UW. Okay, so UW is the answer there. All three are congruent. And Y, we're going to say congruent base angles again. Base angles are congruent. Definitely, because so angle, you know what I can say? I can actually say angle T is congruent to angle X for the first one. Angle T is congruent to angle X. And for this one, I'll say that angle T is congruent to angle W, and that's why. Right? Which is why UT is congruent to UW. All right, VU. VU is congruent to VU is congruent to VY. Why is this? Well, we have, yeah, because we have parallelograms here. Wait, that is congruent to that. If we have that, okay, here's why. Ready? If this angle is congruent to this angle, well, we have our parallel lines because we have corresponding angles, making this angle congruent as well because this one's congruent, meaning that this side is congruent to this side. So we have a lot going on here. VU is congruent to VY. Yeah, that's a lot right there. The reason why is base angles are congruent. Angle U is congruent to angle Y. Also do two parallel lines with corresponding angles. That came from what we stated earlier. Okay, VYU is congruent to VYU is congruent to a lot. VYU is congruent to this one, this one, this one, this one. Wow, it's congruent to a lot. Where do I start? Let's just say angle YU V VYU, let's say VUY. Opposite sides are congruent. I'll just say opposite sides are congruent. All right. So now we're going to get into the numerical parts of this. We have, let's see, we have base angles congruent here. So this will be 50 degrees. We don't know X, but if we know that there's 180 degrees in a triangle and we know 50 and 50 are already there, that leaves us with 80 degrees left over. So X is 80 degrees. And here in this next one, we have 100 as a vertex angle. So we have 180. We don't need that 100 anymore. We only have 80 degrees left. And so these need to be congruent. So these need to be split between whatever's left over. So we're going to do an even split. So we're going to do 80 divided by 2, which is 40 degrees. So this has to be 40 degrees, and this one has to be 40 degrees. Because you're taking your 180, which is your triangle, and you're taking away the 100, which leaves you with 80, then you have to divide by 2 to get these two base angles. Whereas this one, you had 50, so you have 50 because both angles have to be congruent because of this, because of these tick marks. And so what you have left over is 80. So we're going to say x equals 80 degrees. And we're going to say y equals 40 degrees. All right. This next one, You're going to have to work a little bit backwards. We're going to do 110. We're going to do 180, take away 110. That'll give me 70 degrees. That gives me this angle because it's a straight line, so they have to add up to 180. And then that also means that this is 70 degrees. And so now to find angle X, that's my last one. I'm going to do 180, take away the two angles I know. So let's take away 140, which gives me 40 degrees. And there we go. So the measure of angle Y is 40 degrees. And the measure of angle X is 70 degrees. Alrighty, and number 7. So let's see, we have congruent parts right here. We have this item is congruent to this item. We have right angles right here. We have this congruent to, oops, let's use 3 tick marks. So this base angle over here will be 56 degrees. Oh, sorry, 52 degrees. And now we just need to find X. So what I'll do is I will do the, let's see, I'll do 180, take away 90, take away 52. So that is 38 degrees, I believe. Let's see, 50 and 30 is 80, 90, 90 is, yep, so 30. So this ends up being 38 degrees. All right, so in this case, X is equal to 38 degrees. And Y, let's see, 38. And then we also can do Y is equal to 4 because it's congruent. It's a side length, not a degree measure. So Y equals 4. All right, let's find each value here. If the measure of angle L is 58 degrees, so here's measure of angle L is 58 degrees. Find LKJ. So LKJ is this whole angle K right here. Okay, so we want this whole angle right there. Yep. So that would make this one 58 degrees because it's an isosceles triangle, so opposite angles are going to be congruent. I'm going to make it a little bit larger. There we go. So I'm going to do 180. I'm going to do 180, take away 58, take away 58 again. That's 116, so that is at 64 degrees. Yep. So the measure of LKJ is 64 degrees. Okay, if JL was 5, so JL was 5, how long is ML? So I'm going to erase this information because I'm no longer looking for it. Whoops. So in this case, if JL was a total of 5, then how long would ML be, which is 2.5. So these are both going to be 2.5 because the bisector, so we know that these pieces are congruent. So the measure of angle L is the length of side ML is 2.5 units. All right, so now we have JKM is 48. So let's say JKM was 48. JKM is 48. That would make this angle at the top 48. It wants to know what angle J is. Well, this would be 90. These are bisectors. they're angle bisectors and perpendicular bisectors. So we're going to do 180, take away 90 degrees, and take away 48. So we have 90 minus 48 is 42 degrees. 40 and 40 is 80, 90, 90, yep. So this one is 42 degrees. I'll just box the answers just so that we know that these are the answers to the problem. Oops. Okay, and this last one. And now we are given that J is 55 degrees. What would the measure of angle JKM be? Whoops. JKM. So J is 55. Let's erase that. J is 55 degrees. And we want JKM, so we want JKM. We want to know this one up here. So JKM, so I'm going to do 180, take away 90, take away 55. So I'll get 35 degrees. So the measure of angle JKM is 35 degrees. See, JKL was one. Yep. Okay, I think we're done with all those. Again, all I did was I erased the information for each one of these. You kind of had to erase and start all over. Because these were if-then statements. So each one could be true in its own unique sense as long as we reset the information that we're looking for. Here we have the perimeter of our triangle to the right is 20. So our perimeter is 20 units. So perimeter is 20 units. And I have the perimeter in terms of x. So what I do know is that this side has a length of x. This side has a length of 2x minus 5. And this one actually has a length of 2x minus 5 as well because they are isosceles triangles. So I'm going to draw that in, 2x minus 5. And so now to find the perimeter, I'm going to do 2x minus 5 plus 2x minus 5 plus x equals, we were given that it was 20 total units. So this is equal to 20. And I will just move this over a little bit. So 2x and 2x and x makes 5x minus 10. So all I did was combine like terms. So I combined this 2x, and this x. And then I did minus 5 to get minus 10. So I'm going to add 10 to both sides. I get 5x equals 30 divided by 5. X equals 6. And that is what I was looking for, which is one of the answers, 6. Okay, now if I want to put that back in, we can. That would give me, let's see, that would give me 6. That would give me 12 minus 5 is 7 and 7. So my side lengths are 6, 7, and 7, which is a total of 20. All right, looks like we have 3 questions left, and then we'll be doing this in class, the 4 or 5 information in class. That will be quite a long lesson, but we will, I'll finish up with these. These can be a little bit complicated, so let's take each one. Slowly here. So I'm looking at this and I see that we have this side here is congruent to this side here. Well, if that's the case, then its base angles are also congruent. So that's 60. That makes this one 60. And now mathematically, this also has to be 60 degrees, because if you have 180 degrees and both of its base angles are 60 because of it's an isosceles triangle, you then have 60 degrees left over. And now what I can do is I can find this angle right here. This angle has to be 120 because we have a line. A line has 180 total degrees, and one of the angles is 60, leaving us with 120 degrees. So I now have the vertex of my isosceles triangle. Take a look now. This is my isosceles triangle right here. So now that I have 120, I'm going to do 180, take away 120. I have 60 degrees left over. So 60 degrees has to make up this area and this area right here, this degree measure. So I'm going to do 60 divided by 2, and I get 30 degrees. So this angle here is 30 degrees, and this angle here is also 30 degrees. So when it's all said and done, y equals 30 degrees, and x equals 60 degrees. All right, this next one is a regular pentagon, and what that means, the word regular, don't forget, the word regular means congruent sides and angles. Congruent sides, congruent angles. So you have both congruent sides and congruent angles. So we know that we have this is congruent to that, which makes it isosceles. This and that and that. So we have congruent triangles on the left and the right. In the center, I'm going to have another isosceles triangle. Do you see how that's going to have the same side lengths? There's no other way for this to exist if everything is regular. And now the question is like, what are these angles? What is this angle? What's this angle? What's this one, this one, this one, this one, this one, this one, this one? Well, there's a lot going on. Let's take one of these triangles, though. I can actually find this vertex angle. And here's how we're going to find that vertex angle. I'm going to say n minus 2 times 180. That's going to give me the total degree times 180. Whoops, I'm already thinking ahead. The amount of sides of my polygon, which it's 5, that means that there's technically 3 triangles inside, right? So 5 minus 2 is 3. 1, 2, 3. We're going to use the same formula we used before to represent the amount of sides. So we have 3 times 180, which means that 3 triangles adds up to 540 total degrees, because each triangle has 180 degrees, and so 3 of them makes 540. Again, another way of looking at it is just n minus 2 times 180. So this has 540 degrees. So that means that, ready for this? 1, 2, 3, 4, 5 angles add up to 180 degrees, because that is really 50, that's all of its angles. That's angle 1, 2, 3, 4, 5, 6, 7, 8, 9. All the triangle angles add up to 540, but there's 5 in general. So what I can do now is I can actually take n minus 2 times 180, and if I were to divide it by n, it would actually give me the amount per angle. So I'm going to do 5 minus 2 times 180 over 5. So what we're going to do is 3 times 180 divided by 5, which again, we're in the same spot. So we could have just done 540 divided by 5. And what that's going to do, 540 divided by 5, gives us 108 degrees. So I really didn't have to go down this whole step. What I should have done was, instead of doing this information here, I should have just divided it right away by n, and that would have given me here. This is your total and this is per angle, per interior angle, actually, I should say, per interior angle. Let me label as total. And this is per interior angle. So just dividing by that extra n really gives you more information. It gives you that we have 108 degrees is each and every interior angle. Having a problem again here. Okay, it stopped working again. Great. Here we go. All right. So 108 per interior angle. So I'm going to erase this, erase this. All I can put this for is right here, 108, and 108 right here. So now what I want to do is I want to do 180 take away 108, which gives me 72 degrees. And that's what makes up this angle here and this angle here. It also makes up this angle here and this angle here. So if I were to divide this by 2, I now get each piece of that. So I get 36 degrees and 36 degrees. So I get that here, 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 and right there where the y is. And there you go. Now, lastly, I can do 108, take away 36, take away 36, or take away 72. That will give me this angle right here. And then I can solve for these by taking that away from 180 and solving, or take each one of these away from 108. It doesn't really matter what you do. Let's do 180, take away 36, take away 36. Sorry, 108, my bad. 108, take away 36. Let's see, 108, take away 36. Take away 36 is 36 degrees. So this one right here is 36 degrees. And these down here, if you do the algebra, you'll get 108 take away 36, you get 72 degrees. We have stopped working again. I have to reset this iPad. 72 degrees. So these are 72 and 72 degrees. Okay, so what we're going to say is the measure of angle x what I get for x. I did that one in purple. And I did y in light green. So I'll move this one up over here. Whoops. That angle is what, 36 degrees? Okay. And this last one, x. Sorry, I'm just making room here. All right, x is in purple, and that was 36 degrees. So x and y are equivalent at 36 degrees. Okay. All right, I think I realized what was wrong with my Apple Pencil, that the end was falling off, so that should make it much better. We should be able to get through the rest of this lesson. So let's take a look at our next one. Okay, here we have 30 degree. Okay, what do we got? We got 30 degrees. We got an isosceles triangle here. We have an isosceles triangle here. We also take a look at this: two tick marks, two tick marks, two tick marks. Looks like we don't only have an isosceles triangle, but we have an equilateral triangle. So what we know about equilateral triangles is this is 60 degrees. This whole thing here is 60, making this part right here 30. So I'm just going to write that in. And then making this whole part 60. And because that's 30, we also have an isosceles triangle in here. The base angles opposite the sides are also congruent. So we have 30 degrees right there. And then that's 30, because we know it's 30, 30, 60. Okay, so we're pretty much almost done. We actually only have a little bit left. We have well, the first thing I'm going to do is say that x is 30 degrees. That was easy. So now we're going to solve for y. So y right here is going to be 180, take away, there's two 30s in that triangle. So that's going to be 120 degrees. So that is 120 degrees. So y is also, y is going to be 120 degrees. All right, and that is it for this lesson. We'll do 4 or 5 in class, but you can work on your IXLs as well after this and get a head start. All right, good luck.